Friends, today in this lectures we are going to talk about microscopy, and that is very important for MSc candidates who are just preparing for the NET ERF exams. So let's start here, and first of all, let's see what is the use of microscope. That use microscope in for the cell cultures, and like you can see here, and microscope can be of two types. That is simple. In simple microscopes, only one lens is used to magnify the objects, while in the case of compound microscope, you can see here that more than one lens is used. There are several properties of the uh, microscope that microscope, what it does, it magnifies the objects. Okay, so let's first quickly see it that some contents here. Like type of microscope, that is second is bright field microscope, and third is dark field microscope, and fourth is phase contrast microscope, and the fifth is fluorescence microscope, and sixth is confocal microscopes. All these microscope mentioned here are the optical microscope because they use light here. Okay, but there's a microscope in which there is no use of light. Instead of that, we use in electron microscope we use a beam of electrons, and not the light. Okay, so electron microscope is of two types, that is TEM and SEM. TEM is for transmission electron microscope, and while SEM is for the scanning electron microscope. Friends, let's first see key that what is the resolution. So resolution is the minimum distance between two points that can be distinguished by certain microscope like SEM and TEM, etc. Okay, there are other microscope also, like the differential contrast microscope, the ICM, and atomic force microscopes. We are now going to talk about the property of microscopes. There are certain properties which distinguish a microscope and make it more important for biological tools to be observed in labs. Okay, first is magnifications. The like in microscope you will have, if you have used earlier, you could see there will be mark on the microscope 4x, 40x, 100x, etc. Okay, these are the resolution, how many times it is going to magnify the objects. Okay, so its property, first property, magnification, resolution, and contrast. Okay, these are the property of microscope list. And resolution and resolving powers, we can calculate the resolution and resolving power of microscope by the use of Abbe's formula. Okay, first of all, it comes to your mind who discovered the first microscope. The first microscope, firstly, the microscope was discovered Jacques Janssens, and he used for the first time he used a microscope, and he discovered a telescope. He is also inventor of telescope, and what he did, he placed two lenses about each other and watched sand particles to and he found that it was appearing large. Now when we are going to talk about resolutions, we are going to we have some formula that is denoted as resolving power is equal to resolving power is equal to 0.61 lambda per nuclear apertures. Okay, and lambda is wavelength of visible light, and that is from 400 to 700 nanometers wavelength. And nuclear aperture is the, what is nuclear aperture? Nuclear aperture is the light gathering ability of an objective. Nuclear aperture is basically used for objective. Okay, objective lens. Another formula used here at the place of nuclear aperture, we replace nuclear apertures with that equals to mu equal to mu sine theta, and it becomes 0.61 lambda upon mu sine theta, and mu is the refractive index of an specimen or object. Okay, you can see here, so we are going to deal with certain properties here, so okay, and this is, you can see here, there is objective and there is specimen and there is condensers. Okay, and if it is written 4x, then it is called magnifying. So okay, it's going to magnify the object to the 4 times. And here's nuclear apertures. You can see here there is formation of angle between the specimen from which the light is going to strike to the objective lens, and it is going to form an angle, that angle equals sin theta is equal to nuclear aperture by 2. And so we have to remember some refractive index of some substances like air's refractive index is equal to 1, and water 1.33, and glass refractive index is 1.5. So, okay, what is difference between 10x and 4x? If an object is 10x, distance between objective and object is close, very close, compared to 4x. Angular value will increase. This is the specimen at 45 degree. Okay, and this is the 100x. In 100x, what happens? Specimen and condensers are very close to each other. Eyepiece is equals to, it becomes equals to oculars. Okay, let's start first compound microscope. You can see here, so we have used here two lenses. Okay, and the first lens which is near the object is called the objective lens, and the second lens which is near the from where we observe the substances in the microscope near our eyes, and is called the eyepiece. Okay, first what happened, there is object, you can see here. So the object, from object the light is coming and is going to strike on the objective, and it is going to and if when it bends towards and merge to a specific points. And if you just mm, from deviated light, you can see this is the deviated light. This is not a direct light, and it is going to strike your eyepiece, and from where you will see the object. And if you extend this non-directed light to here, the image will going to be magnified. So this is called the virtual image, because direct lights are not meeting here, and the image getting highly magnified. Virtual image, you got it. Okay, second thing is come that what is field view. Field view of how a objective appears inside microscope, that is called field view. We can magnify object more than 100x. After the we cannot magnify object more than 100x because after the aberration arises. Aberration is of two times spherical aberration and chromatic aberrations. Optical aberration can be corrected up to certain levels only, and you will see here that what is optical aberration for these regions. You have if you have put the objects too close, then what will happen, there will be a lot of focal point will be formed here, and this is going to give the chromatic aberrations. Blur image will be formed in chromatic aberrations. Okay, yeah, we can correct the chromatic aberrations, like minimum chromatic corrections. There is, we use for minimum correction, you use objective. You use all the microscope needs to be minimally corrected. Without it, we cannot see the image. Okay. Second, apochromatic objective. Example is fluoride. Apochromatic objective of half kg. It's too heavy because of several lenses are inside the objective, as less as 70 objective lenses are used, and also microscope cut is of its objective. So friends, in this lectures we have talked about microscopes initials and basic informations. From the next lecture we will start, and we will go ahead to cover the rest of the microscopic topics. Okay, Thank you very much for watching.